Okay, in this video we're going to take a look at what we call generalized combinations and generalized permutations. When we've always discussed combinations and permutations before, one of the requirements was that no repetition was allowed. But in these examples we're going to look at specialized types of combinations where you're going to choose R objects from a set of N objects with repetition allowed. So here's an example. How many ways could you pick 5 objects of 3 different types? Now what this could be is something like maybe coins, where you would have 5 coins of either pennies, nickels, or quarters, right? And one example would be to have all pennies, or one example would be to have 2 pennies and 3 nickels, or maybe a penny, 2 quarters, and 2 nickels. Now, if you pick 2 nickels, a penny, and 2 quarters in a different order, these two are really the same result. So we don't want to count the order as different. That's why it's a combination, but we are allowed to have repetition. You can have 2 quarters, you can have 2 nickels, you can have all 5 of the same type. But this is the type of scenario that we're trying to count now. We're trying to pick 5 different coins of 3 different types. And the assumption is that you have to have at least 5 of each in order to be able to pick all 5 of the same. So the idea here is actually pretty complicated if we try to think about all the cases. Well, what if we only have pennies, or what if we have only pennies and nickels? What are all the choices? If we tried to count all these one after the other, we'd be here for a long time. Turns out there's a very clever, not necessarily obvious, but clever way to think about this. We're going to think about the 5 coins as sort of these 5 stars. Right? And when we separate into 3 different types, if you want to make 3 types, right, we could separate them using 2 of these bars. Okay? If you were to put 2 partitions, right, in between the objects, you would have 3 different types. So for example, if I decided to put partitions here and I kept the order pennies, nickels, quarter, this would correspond to 1 penny, 2 nickels, and 2 quarters. Okay? Now if I took the same 5 coins and put my partitions like this, that would mean 2 pennies, no nickels, and 3 quarters. Okay? Essentially, if I want to count up all the different ways I can do this, I can just sort of think about how many ways can I write this string using these characters. And it's essentially a binary system. These could be 1s and 0s, but we just use them as sort of stars and bars to sort of see the objects and the partitions. But essentially, this would be like having a bit string of a certain length with a certain number of 1s. Okay? So no matter which one of these 2 situations you're in, you have 1, 2, 3, 4, 5, 6, 7 characters in your string, and you're going to decide which 2 positions to make bars. If you look down here, you have 1, 2, 3, 4, 5, 6, 7, and you have 2 bars. So the way I would answer this question is 7, choose 2. From the 7 possible positions in this string, how many ways can I put 2 1s or 2 bars? I could have also pick the 5 stars. It turns out that these are equal, and if you get into the math behind the formulas of combinatorics, you'll know why these are in fact equal. Okay? Now there is a formula for this. We could sort of generalize this to n, and we could generalize this to r. And if you have r types, you'll always have r minus 1 bars. Okay? So if we wanted to come up with a formula for this, I don't really like formulas because then I have to memorize it. I'd rather sort of draw out an example and count up the scenario. But we would be having n objects. You would have r minus 1 bars, right? And the objects are the stars. So your string altogether would be n plus r minus 1. And from that, you want to choose either the r minus 1 bars or the n objects. So you could use either of these 2 formulas, combination, right? This is how long the string is, this is how many bars you have, this is how long the string is, this is how many stars you have. So either one of those formulas would work. If you like to memorize formulas, you just have to know what the n and the r stand for, and then go from there. Okay, so let's give a couple of examples here, and then we'll look at a few variations of this. So we have a bagel store. They have 6 different types of bagels: onion, everything, plain, sesame, cinnamon, raisin, blueberry. We can abbreviate them with these letters here. If you wanted to pick 8 bagels at random, what are a few different sets of 8 bagels? Okay, so the first one is not really a computation question. It's more just making sure you understand. So I could have maybe 2 onions, let's say 3 everythings, that's 5, 1 poppy, plain, sorry, 1 sesame, and let's just say 1 blueberry. Right. Another example would be to maybe have 4 everythings, maybe 2 plains, and then let's say 2 cinnamon raisins. Okay, so the idea is you could keep doing this, right? But in general, what you have is here are your 8 bagels. Right. And if you're going to have 6 different types, right? 6 types gives me 5 bars or 5 partitions. Okay, so I can take my partitions and put them 1, 2, 3, 4, 5, and you can see there's 1, 2, 3, 4, 5, 6 different types. Okay, so essentially, if I want to know how many ways I could pick 8 bagels, all I got to do is figure out how long this string is, right? And I know it's got 8 stars and 5 bars, so I know it's 13 characters long. And I want to choose from those 13 characters either where to put the 5 bars or where to put the 8 stars. Right? Now for counting problems, I'm going to assume at this point that you can get your calculator out and actually finish these calculations, but that would be for another lesson. I'm just going to leave my answers like this to show where the calculations came from. Okay. Now if I want to pick 12 bagels, the only thing I'm really doing is changing the number of stars up here. All right. I would have 12 objects with 5 bars. Right? And you can sort of make this like 12 stars if you want to sort of show work, 5 bars, and that gives you the 17 characters, choose 5, right? Or the 17 characters, choose 12. Now there's no need to give 2 answers here. I'll stop giving 2 answers for these, but just to show you that they're equivalent. Okay. Once you decide where to fill in the 12 stars, you've all, by default decided everything left over gets filled in with bars and vice versa. Okay, so now let's say we start putting some stipulations or conditions on these. Okay, so let's say now you wanted to pick 12 bagels at random with some conditions here. 12 bagels at random, you want exactly 1 sesame and exactly 2 everything. Okay, so if you're behind the counter, you're going to take those 3 bagels out and put them in the bag. You're still going to have 9 bagels left to choose from. Okay, now we started with 6 types of bagels, right? We started with 6 types. Right? But we said we were going to have exactly 1 sesame and exactly 2 everything bagels. That means that we already put all the sesames and everythings we want into the bag. Right? So we don't have 6 types anymore. Now we only have 4 types left to choose from. So those other 9 bagels are going to have to come from the remaining 4 types, which means you're going to have 3 bars. All right, 3 partitions. That's not 31, that's a 3 and then a partition. So you're going to have a total of 12 characters in your string, and we're going to choose 3 of them to be the bars, or you could have said 12, choose 9. Okay. If you're putting exactly some of certain types in, you basically just remove those from the leftovers that you still have to pick. But then you also have to remove those types because you can't get any more of those. Okay. Now this is a little bit different. Here in this one, you want to pick 12 bagels, but you want at least 1 sesame bagel. Okay, so if I know I want at least 1 sesame bagel, right, and no everything bagels, if I know I want at least 1 sesame bagel, I would put 1 bagel in the bag. Right, so I'd still have 11 to choose from. Right, and I started with 6 types. Right, having at least 1 sesame means I'm still allowed to pick from the sesame bin. Right? But I want no everything bagels. Since I want no everything bagels, that means I'm only choosing from all 5 except for the everything. So I'd have 11 stars and 4 bars, and that's going to give me 15 choose 4 or 15 choose 11. Okay, this takes some practice. Right? There's certainly more examples we could do. Sometimes you could say you want no more than. No more than is a little bit more complicated, but there's a difference here. If you're wanting exactly a certain amount of a certain type, put them in the bag and don't choose any more. If you want at least a certain amount, put them in the bag, but still allow yourself to choose more of those. Okay. If you wanted know everything bagels, right, you remove one of the types. You just can't choose any more of those type. Okay. In the next video, we'll look at the generalized permutations, where the order does matter. In this case, the order doesn't really matter. We sort of set the system up here to make it look like the order matters, but really the order of these stars here doesn't matter. Okay? Give it some practice, look at a few different variations, and see what you can do.